Hello everyone, welcome back to Think Lab by Saurabh. So in this video, we are going to learn the natural language processing from the scratch to an advanced technical level. So by end of this video, you will understand how ChatGPT, Google Translate, Grammarly, and AI search engine, voice assistant, and modern AI agent process the human language. So let's begin. So first, what is the natural language processing, right? So natural language processing or NLP is a branch of artificial intelligence that enable computer to understand, interpret, generate, and reason over the human language. So natural language processing includes the English, Hindi, French, Chinese, and even language human naturally speak. So the biggest challenge is to computer to do not understand the words. So computer only understand the number, right? So therefore, every NLP system convert human language into the numerical representation before any machine learning model can process it. So this approach happened through the NLP pipeline, right? So the first stage is the data collection. So inside the NLP pipeline, so there are several steps. So we are starting with the step first. So the first stage is the data collection. So every NLP project start with the text data. So data may come from the emails, chat, conversation, customer review, research paper, PDF, web page, books, social media, support tickets, legal document, or any media report, right? So the quality of data determine the quality of the final model, right? So this why we people say garbage in, garbage out. That is the important thing, the quality of data. So now we are moving to the second stage, the text processing. So raw text contain many unnecessary element, right? So example, include the punctuations, emoji, HTML tag, URL, duplicates, space, special symbol. So these are the all the unnecessary element, right? So we have to perform the pre-processing, right? So the pre-processing pipelining usually consists of multiple operations, right? So the first operation is the case normalization. It means all the text converted into the lower case. For example, if the artificial intelligence is written in the capital, so we have to convert into the lower case, right? So this reduce, just once we convert upper case to lower case, so this reduce the vocabulary size, right? And the second operation is the noise removal. So noise includes HTML tag, XML tag, punctuations, email address, emoji, hashtag, and some kind of a special character. So we have to remove this kind of all the noise removal. We have to perform that. So removing noise improve the model quality. So that's why we try to remove it. So the third operation is stop word removals. Words like the, is, are, of, to. So it's appear frequently, right? So we have to remove this stop word, right? So this word often contribute the little semantic meaning for many machine learning tasks. But however, modern transformer model sometimes retain the stop words because they contribute to to the understanding part, right? So the fourth operation is the tokenization, right? So we have to perform the tokenizations. So what is the meaning of this tokenization? So tokenization is split text into the smaller unit of tokens, right? So we have a bigger text, so we just divide it into the smaller unit, and this smaller unit is called the tokens. So there are several types of tokenizations, like word tokenization, so split the sentence into the words. Sentence tokenization is there, that separate the paragraph into the individual sentence. Character tokenization is there, they split the text character by character, right? So modern large language model use the subword tokenizations. So there are popular tokenization algorithm include the bytes pair encoding, word piece, sentence piece. Subword tokenization that is a very efficient to handle the unknown words or reduce the vocabulary size. So the next step is the pre-processing, right? So next pre-processing step is the stemming, right? So stemming remove the suffix to obtain the root form. So for example, playing, played, plays become, all these three words become the play, because this is the, we are in the different tense, like playing, played, plays, right? So we just perform the remove the suffix and we obtain the root form. So the root form is the play, and the algorithm is simply and fast but many times generate the non-dictionary word. So next technique is the lemmonization, right? So unlike stemming, lemmonization use the vocabulary and grammar's rule, so it returned the meaningful dictionary word. For example, running becomes run, study becomes study, better become good. So lemmonization is just a computational, more expensive but more accurate. So next stage is the text normalization. So normalization is standardizations, so we try to check the spelling mistake, we try to check the slangs, we try to contraction we have to perform that, like, if you're taking the can't, becomes, that can't becomes cannot, right? You becomes you. BTW becomes by the way. So we have to normalize to improve the consistency across the data set. So now the text is clean. So, but the machine still cannot understand the text. So next we have to perform the feature engineering. So feature engineering convert word into the numerical vector, So that is the oldest technique, that is called we bag of the word, right? So bag of the words build the vocabulary from the corpus, right? So each document become a vector contain the word of frequency. So order of, this order of word is ignored. So advantage is very simplicity, right? So the disadvantage of loss of context and the semantic. So the first technique is called a TF-IDF. TF stands for the term frequency, IDF stands for the inverse document frequency. So TF measure the how often a word appear in the one document. IDF reduce the importance of the word that appear in the almost every document. So this TF-IDF highlights the informative words. So okay. So all the better than the bag of word, TF-IDF still cannot be understand the word meaning, right? So the next evolution is the word embedding. So word embedding represent each word as the dense vector, right? So instead of a sparse frequency vector, every word is represented using the hundreds of numerical dimensions. So semantics, the similar words appear to close to the that close together in the vector space. So popular embedding algorithms include the word to vec, like fast text, sentence embedding, right? So word to vec, just word to vec introduce two training method. Continuous bag of word predict the target word from the surrounding content. Skip gram is also there. Skip gram predict the surrounding word from the target word. And there are also like fast text also there. So therefore it's performed the better on rare word, and also give the rich language. Sentence embedding extend the concept of, represent entire sentence for the paragraph. So modern semantic, research the system that rely on heavily on the sentence embedding. So next major breakthrough was the deep learning, right? So the recurrent neural network process the sequential data. So they maintain the hidden state, to capture the previous information. So however, RNN suffer from the, some kind of problem, right? So like long-term sub memory, long short-term memory network solve this problem using this memory cell and getting mechanism. So getting that getted recurrent unit, simply we call LSTM, while maintaining the similar performance. So all the effective RNN based on the model process text sequentially and making the training slow. So the text, it just text revolution was, we have to perform in the transformer architecture. So the transformer architecture was introduced and the paper of attention is all you needed. So instead of, a recurrence transformer use the self attention mechanism, right? So self attention allow every token to interact with each, every other token in a sequence, right? That is a self attention. Every token to interact with the every other token in the sequence. So this enable the better conceptual understanding and massive parallelizations of during the training. So the transformer architecture contains three core components like input embedding, positional encoding, and multi-head self-attention. So these are the followed by the feed-forward network, or we call the layer normalization or residual connection, right? So modern large language model based on this architecture, right? So BERT is a like encoder transformer. BERT is an encoder only transformer. So it optimizes the language understanding. GPT is called decoder only transformer. So it optimizes the text generation. So encoder decoder models such as the T5 and the BERT perform the sequence to sequence task, like translation and summarization. So today large language model extended the transformer using the billions of parameter and the massive data sets. So they perform reasoning, coding, summarization, translation, retrieval, and the conversational AI. So NLP supports in the many world application, like sentiment analysis. So that determine the customer opinion, named entity in the conversation, identify the organizations and location and data set, part of speech, and also dependency parsing, identify the grammatical relationship, machine translation, like questioning answer retrieval practices, text classification, they can perform, topic modeling, discover hidden themes, text summarization, generate the, concise summary. So semantic search retrieve the information based on the meaning rather than the keywords. So modern retrieval augment generation system combine vector database with large language model to improve the factual accuracy. So vector database such as Pinecone is there, ChromaDB is there, LansDB is there. So there are lots of high dimensional embedding for simulatory search. So embedding models convert document into the vector, and simulatory search retrieve the most relevant document. So the retrieve context is passed to the LLM, and they response to generation, right? So this architecture is called this architecture is called RAG, Retrieval Augment Generation. So modern AI agent extended RAG with the planning memory, tool uses, and reasoning and workflow execution. So today, almost we in the production AI system combine LLP embedding, vector database retrieval system, and large language model. So there are popular Python library that include NLTK is there, scikit-learn is there, Hugging Face transformer is there, PyTorch is there, TensorFlow, LangChain, Llama Index, sentence transformer is also there. To summarize this concept of NLP pipelining, so there is a several step in this pipelining. First one is a data collection. We have to perform the text processing. Tokenization is there. Normalization is there. Feature engineering we have to perform. Embedding is we have to perform. Deep learning, transformer, large language model, vector search, retrieval augment generation, and AI agents. So this is a complete evolution of natural language processing from rule-based system to modern generative AI. So understanding this concept provides the strong foundation for production graded AI application. So thank you for watching. If you found this video very helpful, to subscribe to Think Lab by Saurabh for the more deep technical content on AI, machine learning, and data science, LLM, RANG, MCP, or AI agents. So see you in the next video. Thank you.